Hello, and welcome back to Teacher Gimble's channel. Today we're going to be talking about Illustrative Math, Algebra 1, Unit 2, Lesson 4, and we'll do the practice problem set together. If you like this video, please like and subscribe so you can make more like it. Alright, problem 1. An artist is selling children's crafts. Necklaces cost $2.25 each, and bracelets cost $1.50 per each. That's a little odd wording, but that's okay. Select all the combinations of necklaces and bracelets the artist could sell for exactly $12. All right, so we have our necklaces at $2.25 and our bracelets at $1.50. Let's do some calculations here. Now, I'm going to be doing mental math. However, if you have a hard time with mental math, make sure to pull out your handy dandy calculator to make sure that you're keeping up with me. 5 necklaces at $2.25 each are going to be 5 times $2.25. That's going to be the total cost of the necklace plus 1 bracelet, which is $1.50. 5 times $2.25 is 9, 11, 25 plus $1.50, which gets you a total of $12.75. B. 2 necklaces and 5 bracelets. So 2 necklaces, that's an easier thing to calculate, is going to be 2 times $2.25 plus 5 bracelets, which is 5 times $1.50. This is going to get us $4.50 plus $7.50. And 4 plus 7 is 11, plus an extra dollar is going to get us $12. $12. That is the answer for B. So we just have to multiply the number of bracelets and necklaces by the cost. 3 necklaces and 3 bracelets. So 3 necklaces at $2.25 each plus 3 bracelets at $1.50 each. This is going to be $4.50 over here. And this is going to be $4.50 plus $2.25, which is going to be $6.75. 6 plus 4 is 10, plus an extra $1.25 is going to be $11.25. That is the cost. D. 4 necklaces and 2 bracelets. So our necklaces are $2.25 each, plus our 2 bracelets, which are $1.50 each. This is going to be $3. This is going to be $9, which is going to get 12. We want all of the combinations that get exactly 12. So even though we've already found D, which is 12, and we've already found B, which is $12, we're going to have to keep going until we find more. But let's start doing some process of elimination rather than all of the math. So 3 necklaces and 3 bracelets were $11.25. So 3 necklaces and 5 bracelets with a bracelet at $1.50 each is definitely going to get us above $12. So we can cross that out right now, because we only need 75 more cents to get to 12, and bracelets cost $1.50 each. 6 necklaces and no bracelets. Well, let's calculate the cost of 6 necklaces, which is $2.25. Immediately, I know what I'm going to multiply. It's going to be 6 times 2, which is 12, and then 6 times 25, which is an additional $1.50, which gives me $13.50. So this is not correct. No necklaces and 8 bracelets. In this case, it's 8 times $1.50. 2 bracelets are each $3, and we have 6 sets of 2. 4 sets of 2, because it's 8, let's get just $12. So this one is correct. So the goal for mathematics is to work smarter and not harder. So once I started to see a pattern of the different costs, definitely take into account that you can look at the pattern and see if it's going to be above $12 or below $12. In this case, you could also plug it in for each value to do that computations on paper, but you got to do whatever's easiest for you. Pause the video if you need a second to go back over those calculations as I go on to question 2. Diego is collecting dimes and nickels in a jar. He has collected $22.25 so far. The relationship between the number of dimes and nickels and the amount of money is represented by the equation 10 cents times dimes plus 5 cents times the number of nickels equals $2.25. Select all the values D and N that could be the solutions to the equation. So when we have parentheses like this, they usually represent, oops, my pencil's not working. They usually represent our X and our Y. This is what we plug in. This is our output. And this is a general rule for our equations. You might not have seen the x and y notation yet, but this is what we're going to do. So we want something that is going to be the solution to the equation. Now, if you've seen this before, we're actually not going to use this now because they give us a little guide up here, which is telling us to do something different. So in this case, this is going to be equivalent to d comma n, which tells us d is equal to 0, n is equal to 445. This tells us this is how we're supposed to plug what we're supposed to plug into the equation. So I'm going to rewrite my equation, and instead of d, I'm putting 0 plus 0.05 times 445 is it equal to 22.25. So I'm going to do a few calculations up here just because that mental math I don't have, and it is correct. Let's go ahead onto the next one. So we have to remember here, this represents our D, this represents our N. So D in this case is going to be 50 cents, and N in this case is going to equal 0.05. So our equation that we're going to use is the same equation up here. We're just going to plug in 0.5, so plus 0.05 times 50 cents times N, which is 435, is equal to 2.25. Now, I'm a little bit confused by this 0.50. And so in this case, I'm just going to assume that instead of a dime, this is actually a half a dime, which means another nickel. And so if we have another nickel over here, which gets us 1 times 5 is 0.05 like this, we're actually going to have we're going to have 0.05. The total number of nickels we have is going to be 436. Now, I know I need 445 nickels to get me to 22.25, so I can cross out that answer without doing any more math. Let's go on to this question. In this case, we have our dimes are equal to 233, plus our nickels are equal to 21. Now, I'm going to stop doing this equation because I'm going to do a little bit of mental math. 10 cents are each of our dimes. So if we have 233 dimes, that means we're going to have $2.33. Plus, or we're not going to have $2.33, we're going to have $23.30. Plus 21 nickels. So it's 21 times 0.5. So how many cents do we have? We're going to have $1.05 because if we have 20 nickels, make up $1. So we're going to have extra $1.05. When we add together, that's not going to get us to 25. So we're done. Next question. 118. So this is our dimes. If we have 118 dimes, that's going to be $1.80. If we have 209 nickels, well, 200 nickels are going to be $10. Plus the extra 9 nickels is 9 times 5 is 40, is going to give us 40 cents, which is going to get us 21. Plus 80 plus 40 is 20, which is actually going to get us 22.20, which is really close, but not quite. And I lied because 9 nickels is 45, which actually gets us 22.25. So this is correct. Now remember, when you're doing mental math or I'm showing mental math, make sure to double check it in a calculator. Now we have this last question here. Here we have 172 times, which is 17 and 20 cents. And then we have 101 nickels. So we know 101 nickels means that we have 5 sets of 20, which is going to be $5. And then one left over, which is an additional 5 cents. When we add this together, that gets us 22.25. Now, this formula that I did for the first 2 questions, you can use for every single questions. However, you might see your students, or you might be tempted to do some of this in your head by calculating nickels and dimes more intuitively, which I welcome you to do if that makes sense to you. All right, so do whatever makes most intuitive sense that allows you to check that equation. There isn't one right way. If you need to pause the video now, pause it as I move on to the next question. Volunteer drivers are needed to bring 80 students to the championship baseball game. Drivers either have cars which can seat 4 students or vans which can seat 6 students. The equation is 4c plus 6b is equal to 80, describes the relationship between the number of cars C and the number of vans V that can transport exactly 80 students. Select all statements that are true about the situation. So 4 cars plus 6 van is equal to 80. We have 80 students total. If 12 cars go, then 2 vans are needed. So if we have 2 vans, that means we have 12 students. And then how many cars are we going to need? Well, if I'm not sure how many cars, so I'm just going to do a little bit of math over here. I'm going to solve my equation by subtracting the 12 from both sides. And in this case, it's going to be 68 divided by 4c. And I'm going to divide both sides by 4, which is going to tell me I need 17 cars. So if 12 cars go, we're going to need more than 2 vans. Pause if you need a second to go over this, because I'm going to go ahead and look at the next question. The pair C is equal to 14 and V is equal to 4 is a solution to the equation. So let's pop it in. 4 times 14 plus 6 times 4 is equal to 80. Well, 4 times 14 is going to be 56, plus 6 times 4 is 24 is equal to 80. 56 plus 24 is equal to 80. So yes, it is a solution. Let's go on to the next question. Again, pause the video if you need to look over what I just did. If 6 cars go and 11 vans go, there will be extra space. So we're not looking to see if this is true. We're trying to see if we have extra space. So 6 cars would be 4 people per car, would be 6 times 4 is 24, plus 6 times 6 per van is going to be 66, and that is going to equal 90, which means there will be extra space. Yes, that is true. If 10 cars and 8 vans is not enough to transport all the students, well, 10 cars is going to be 40 students, because 10 times 4 gives you 40, plus 8 times 6 is 48, and that's going to get you 88. So this is not true, because it is enough to support the students. If 20 cars go, no vans are needed. So let's see, 4 person per car, 4 times 20 is 80. This is true. We wouldn't need any vans to fit the 80 students. 8 vans and 8 cars are numbers that meet the constraints of this situation. So 8 cars, we just calculated. Well, 8 cars by 4 people, that is going to be 32 cars. Plus 8 vans, that's going to be 8 times 6, is going to get you 48 cars. This is going to get you 80. So yes, 8 vans and 8 cars meet the constraints in this situation. So this requires a lot of multiplication and some arithmetic, but it isn't a very difficult question to problem through. There was no way that I saw I could do some quick cheats to kind of compare these to some of my other answers to calculate it, but if you see it, feel free to go ahead and do it. Let's go on to the next question. Problem 4. The drama club is printing t-shirts for its members. The printing company charges a certain amount of each shirt for setup plus a setup fee of $40. There are 21 students in the drama club. If there are 21 students in the club and the t-shirt order costs a total of $187, how much does each t-shirt cost? Well, we have $181.07 that was spent. We know 40 of those dollars was the setup key. So I'm going to just subtract those 40 and be left with $147 that was spent. Now we have 21 students, so we're just going to divide it by 21. Now I'm going to simplify my fraction before I divide. So I divide the top by 7, and I'm going to get 21, and we'll divide by bottom by 7, and I'm going to get 3, which tells me 21 divided by 3 is $7, which is the $7 that each student spent on the t-shirt. Number 2. The equation 201.50 is equal to F plus 650 times 21 represents the cost of printing the t-shirts at a second printing company. Find the solution to the equation and state what it represents in this situation. Well, in this case, each student is definitely paying less because it's 650 times 21. Let's do a little bit of mental math over on this side and say 056 0001 13. And when we multiply that, we're going to get $136.50. So students spent $136.50 as compared to $147. This is the total amount that was spent. So now we're going to calculate what F is. I'm going to calculate F by subtracting this value from both sides. 136.50, 136.50. Now, there's ways you could do this that looks a little bit neater where you stack it up, but I think the intuition is much more important than stacking things correctly. So this is a 20, which turns into a 19, which turns into a 5, which is a 6. We are left with a 65 is equal to F. And this over here represents the startup cost. So each student pays a little bit less, but we have a startup cost. However, the equation, you end up seeing that you actually end up paying more for teachers overall for problem 4. Problem 5. So pause the video now if we need to go over and think about what I just did. Problem 5. The box plot represents the distribution of the numbers of children in 30 different families. After further examination, the value of 12 is removed for having been recorded in error. The box plot represents the distribution of the same data set but with a maximum 12 removed. The median is 2 children for both plots. And I can see that on my box plots like that. Explain why the median remains the same when 12 is removed from the data set. All right, so if more than one family had 2 children and more than one family had 2 children, the median, when you remove a piece of data from a data set, is only going to shift 1 or 2 values up or down, or average of a half a value up or down. So if you have multiple values of 2, shifting to the right or shifting to the left is going to keep your median at 2. So it's not actually going to make a difference. However, when 12 is removed from the data set, does the mean remain the same? Well, when you remove a large value from a data set, the mean always is going to shift to the left. So when you have an extra large value of the data set, the mean, and you remove it, the mean gets smaller. If you have an extra small value of a data set and remove it, the mean will get larger, because adding that extra value is going to pull the mean in the direction of that value. If you need some help with this, go back to earlier videos to make sure you reviewed that concept. Problem 6. The number of points Jada's basketball team scored in their games have a mean of about 44 and a standard deviation of 15.7 points. Interpret the mean and standard deviation in the context of Jada's basketball team. Well, what that means is, on average, they tend to get about 44 points per each game. However, there's a deviation of 15 points, so sometimes they score above 44 points, and they can score up to 50, 60 points above 15, and it's still pretty normal, or they score 15 below, or 15.7 below, so they can score as low as 30, and it's still a pretty normal value. And that's what the standard deviation says. It deviates by about 15 points, both higher and lower, and that's pretty standard within the values of the data that they have. Pause the video if you need to think about that a little bit longer. Kieran's family is having people over to watch a football game. They plan to serve sparkling water and pretzels. They are preparing 12 ounces of sparkling water and 3 ounces of pretzels per person. Including Kieran's family, there will be 12 people at the gathering. A bottle of sparkling water contains 22 ounces and costs $1.50. A package of pretzels contains 16 ounces and costs $22.99. Let N represent the number of people watching the football game. S represents the ounces of water. P represents the ounces of pretzels, and B represents Kieran's budget in dollars. Which equation best represents Kieran's budget? So we're going to use our variables to connect to our numbers and figure out which each one means. 12 times S. S is the ounces of water. So if we have 12 times S, that's going to be 12 ounces per person. So that number makes sense over here. 3 times P, which is 3. Well, we have P is ounces of pretzels, and we have 3P, so that's the ounces of pretzels per person, which also makes sense, is equal to B, our budget. That doesn't make sense because this over here, S and P are in ounces and budget is in dollars. So we cross them out. 12 times 10, so 12 ounces per 10 people. That value makes sense. 3 times 10, 3 ounces per 10 people, also makes sense. Again, this is equal to B. B is in dollars. Those are in ounces. It's not good. Let's see. 150 times S. Well, 22 ounces cost 150. This is saying each ounce costs 150. So immediately we know that this term doesn't make sense, so we cross it out. 150 times 6. Well, let's think of where we got 6 from. Plus 299 times 2 is equal to B. So 150 is the cost, and it looks like they bought 6 bottles of sparkling water, which would make sense. And 299 is the cost of pretzels, and they bought 2 packages of pretzels, also makes sense. And these are both in terms of dollars, so that's going to equal our budget. So D is the only one that makes sense in this context. Let's go on to the next question. The speed of an object can be found by taking the distances traveled and dividing it by the time it takes to travel to that distance. So let's write that out. We have the speed of an object is the distance traveled over time. So speed, distance, and time. An object traveled 100 feet in 2.5 seconds. Let S be the speed measured in feet per second. Write an equation to represent the relationships of the 3 quantities. Well, we have S. This distance is 100 feet. Don't forget your units. Over the time, which is 2.5 seconds. There we go. Our distance, our speed is 100 feet by 2.5 seconds. Oh, that's a 2.5. I knew I made a mistake. And there we go. We're done. Last question. A donut shop made 12 donuts to give to a school's math club. Which expression represents how many donuts each student would get if the donuts were equally distributed and there were X students in the math club? Well, we have 12 donuts by X students. We have 12 dozen donuts. So the number of donuts is not 12. The number of donuts is 144. Now, X is the number of students in the math club, so we're going to divide the 144 donuts by X. So which one of these looks like the equation? Well, obviously, this is the number of donuts. That's not correct. And this is the students divided by the number of dozens. Also does not make sense. 12 times 12 times X is not that equation. However, 12 times 12 over X is the same thing as 12 times 12 over X, which gets us the correct answer. All right, I hope this lesson helped with your intuition about equations. If you have any questions, please leave them in the comments. And if you like this video, make sure to like and subscribe, and I will see you in the next one.